Module 8, Lesson 3 deals with the area of trapezoids. The pacing guides claims that this one's going to be a 2-day lesson, and that honestly wouldn't surprise me too much, as trapezoids are some pretty tough little critters to work with. We have 17 resources to work through, starting off with an introduction that says the I-Bank building in Venice, Italy was designed to work with the surrounding landscape and maximize efficient energy use. The surrounding walls are trapezoids, which deflect solar heat and still allowing natural light from the sun to warm and brighten the building. The two trapezoidal walls are going to be 12 meters high and have parallel bases that are going to be 33 and 54 meters high. And without using an area formula for without using the area formula for a trapezoid, how can you use what you know about the area of triangles and rectangles to find the area of that trapezoid? Well, you'd have to cut that sucker up into some pieces to do it. It sure would be nice if we had something easier, like, I don't know, maybe a formula for the area of a trapezoid. A trapezoid, of course, is defined as a quadrilateral with one pair of parallel sides. To find the area of a trapezoid, we first decompose or break down the trapezoid into triangles and a rectangle. Since you know the formulas for the areas of triangles and rectangles, you can find the area of each smaller section and then add them together to find the area of a trapezoid. So let's first watch a video on decomposing that trapezoid and to find this area.
A trapezoid is a quadrilateral with one pair of parallel sides. You can find the area of a trapezoid by decomposing it into triangles and other polygons. This trapezoid is made up of one rectangle and two congruent triangles. To find the area of the trapezoid, find the area of the shapes that make up the trapezoid. First, find the area of the rectangle using the area formula. Use the formula to find the area. The area of the rectangle is 54 square inches. Next, find the area of one of the triangles using the area formula. The area of the triangle is 12 square inches. The two triangles are congruent, so the areas are the same. Then, find the trapezoid's area by adding the areas of the polygons that make up the trapezoid, the rectangle and two triangles. So, the area of the trapezoid is 78 square inches.
Well, that's pretty straightforward. You're going to cut that trapezoid up into a rectangle and one or two triangles, depending on the shape of the trapezoid. Find the area of each individual piece and then add it all together. So from here, let's keep moving and see what else they have to say to us. Example 1, find the area of the trapezoid by decomposing. And what have they given us here? Well, they've given us a big honking trapezoid here. So, first question, how can you divide the trapezoid into shapes that you're familiar with? Well, I can see a rectangle here, I can see a triangle here, and I can see a triangle here. This triangle, I don't think is going to be the same size as that triangle, though. Let's take a look at what I'm talking about here. So they want us to move through the slides, and you can see that we have a total of 10, I'm sorry, let me go back here to the bottom here. We had a total down here, you had 10 is this distance, 2 is this distance, and 7 is this distance right here. That means that the length from here to here is going to be 10 minus 7. And you can see that would end up being 3. So now you have a triangle here with a section of 3. You have a rectangle that is going to be a 7 by 5. And you have another triangle here with a section of 2. And of course the height of both triangles is going to be 5 as well. From there, you're going to have to break those into 3 separate pieces, find the area of each individual piece, and then work towards finding the final area of the entire figure. Now they've made some pretty big leaps in finding the area of these different things, but so we're going to take on the triangle on the left. 3 times 5 is 15, and half of 15, that's going to be 7.5 inches. The triangle on the right, 2 times 5 is 10, and half of 10, that's going to be 5 inches. And then for the area of the rectangle, 7 times 5, that's going to end up being 35. Check those. All 3 of them check. Now we're going to move from there on to the next level, where we're going to take and add those up. So we have the 35 inches plus the 7.5 inches squared plus the 5 inches squared, and all that's going to end up equaling 47.5 inches squared for your final answer. So we decompose that trapezoid into 3 separate shapes, 1 rectangle and 2 triangles, and found the area of each one, added those areas up to get us to having that final answer. Now it's going to be your turn to pause this video and decompose this trapezoid. You only can have 2 figures in it when you decompose it. Find the area of each figure, add them up to find the total area. So the first thing I want to do is cut this up into a triangle and a rectangle. So my cut I'm going to put right along here. And you can see that I've got, oops, messed up my touch here. I've got myself a nice rectangle and I have a nice triangle. Now I know that this distance here, that's become 3.8. The entire distance is going to be 7, so I'm going to take right there 7.0 minus 3.8. We'll do some subtracting here. That's going to become 10 minus 8 is 2, 6 minus 3 is 3, so this distance right here, that's going to end up being our 3.2. Next, we're going to work on finding the area of each of our pieces here. So I've got a rectangle and I've got a triangle I need to work with. My rectangle has a formula that says area is equal to base times height, or you may have used length times width. Area is equal to, I have a base of 3.8 units and a height of 8.2 units. That means the area is going to equal 2. And let's go ahead for time's sake and do 3.8 times 8.2, which is going to give us 31.16. So that's going to be 31.16 units squared. And then we have the triangle formula, which is area is equal to base times height divided by 2. Area is equal to, I have a base of 3.8 units times a height of 8.2 units. I'm sorry, this base is going to be 3.2 units right there, so let me fix that. I was looking at the wrong shape. So I have the 3.2 is going to be the base of my triangle, and the height's going to be the same, and that we're going to divide entirely by 2. Now this is a place where I would simplify before I multiplied. 2 goes into 2 once, and 2 goes into 8.2, 4.1 times. That means I'm going to have area is equal to, well, I'm going to take my 3.2, multiply it times my 4.1, and that's going to give me 13 and 12 hundredths over 1, also known as 13.12. Final stage of the problem is to add those 2 numbers up. And when I do that, I get an 8, a 2, a 4, a 4, and my decimal comes down. So 44 and 28 hundredths should be the total area for the entire shape. Check the answer, and the answer checks. This is your supporting work. This is what I would expect to see to get credit for this problem. Next, we're going to watch another video. This time we're going to find the area of trapezoids by composing, meaning putting them together. 2 congruent trapezoids can be composed or combined to form a regular parallelogram. Since you know the formula for the area of a parallelogram, you can use that formula to help find the area of a trapezoid. Watch this video and we're going to see how to do it.
Find the area of a trapezoid. A parallelogram can be used to find the area of a trapezoid. Trace the trapezoid on the grid paper. Flip the trapezoid over so the shorter base is on the bottom. Align this trapezoid with the right side of the one on the grid paper. This is a parallelogram that is composed of two congruent trapezoids. Find the area of the parallelogram. This parallelogram has a base of 20 units and a height of 8 units. So the area is 160 square units. Because the parallelogram is composed of two congruent trapezoids, the area of one trapezoid is half the area of the parallelogram. So the area of the trapezoid is 160 divided by 2, or 80 square units. Try another one. Trace the trapezoid on the grid paper. Flip the trapezoid over so the shorter base is on the bottom. Align this trapezoid with the right side of the one on the grid paper. This is a parallelogram that is composed of two congruent trapezoids. Count the units in the base and the height. This parallelogram has a base of 18 units and a height of 6 units. So the area is 108 square units. The area of one trapezoid is half the area of the parallelogram. So the area of the trapezoid is 108 divided by 2, or 54 square units.
Well, I've actually never seen that before, but that's a pretty smooth way to solve the area of a trapezoid using parallelogram formulas. I actually kind of like that. And that leads us to learn number 2 for this one, which says to find the area of a trapezoid using the formula. The formula for the area of a trapezoid is derived from the formula for the area of a parallelogram. The formula uses a trapezoid's basis, that's going to be a vocabulary term, and its height. And then once again, these may or may not be the same vocab definitions you had for the other basis and heights that we looked at. You've got several vocab quizzes in this chapter. You need to know the difference between them. So what are we going to look at here? Well, the basis, you've got base sub 1 and base sub 2. That's how you say it when you have that little number there. So you've got two parallel bases, base sub 1 and base sub 2, and you have a height, with the height being the distance between the two parallel bases. Remember, your base and your height always meet at right angles. From there, we get to have a whole nother video about how to solve these problems.
A trapezoid is a quadrilateral with one pair of parallel sides. Each parallel side is a base. In the trapezoid shown, base 1 is the shorter base, and base 2 is the longer base. The height, h, is the perpendicular distance between the bases. You can find the formula for the area of a trapezoid by composing a parallelogram. First, make a copy of the trapezoid. Next, rotate the new trapezoid. Note that now base 1 is the bottom side and base 2 is the top side of the second trapezoid. Combine the trapezoids. The two congruent trapezoids form a parallelogram. The area of a parallelogram is the product of its base b and its height h. The area of one of the trapezoids is half of the area of the parallelogram. The height of the parallelogram is the same as the height of the trapezoid. The base of the parallelogram is the sum of base 1 and base 2 of the trapezoid. So, the area of a trapezoid is 1/2 of the product of its height times the sum of its bases.
And that is the formula we're going to be using a lot for solving this throughout the rest of your mathematic career in middle school and high school as well. Now, I do want to point out a place that many students make a mistake is this plus sign. They turn it into a multiplication symbol. It's not a multiplication sign. It's always going to be a plus sign that goes right here. So finishing up this part 1 of our lesson, in words we could say that the area of the trapezoid is 1/2 of the product of the height and the sum of the bases, base sub 1 and base sub 2. In symbols, we would have a formula that says this: area is equal to 1/2 times the height times the sum of base 1 and base 2. And when we come back for part 2 of this video, that's where we're going to start. We're going to be using the information that we've learned in that formula and applying it to example 2 to find the area of the trapezoid. I'll see you in video part 2.